So what makes the spectrophotometer scan? Or rather, I should be more specific, what makes the monochromator inside of the spectrophotometer scan? If you're using solid state instruments like a diode array or a CCD, there's nothing actually scanning. What you're doing is you're dispersing light into its constituent colors and detecting all of that simultaneously. There's no actual moving parts, which is why I said it was a solid state apparatus. A scanning spectrophotometer, on the other hand, is literally changing the color of the light that the sample sees as it scans, as it sweeps through the wavelength. How is that rainbow of colors created in the first place? There's two types of spectrophotometers, generally speaking. You've got prism monochromators and you have grating monochromators. And while we use a prism grating for UV vis near infrared, the majority of our products are grating monochromators. And a grating, just to remind you, is a mirrored surface with potentially hundreds of lines, even thousands of lines etched onto it in order to create the rainbow. Now, if you have a really large surface like this, obviously it's going to be quite difficult to move rapidly. So how does one get a fast scan? Manufacturers go to increasingly smaller gratings in order to move them more rapidly. The trouble, of course, is that you then have a smaller surface off which the light is coming, and so you have lower light throughput. You might have higher stray light characteristics, and of course there's a very finite rate at which you can move something even the size of your thumbnail. It can only go so fast. There was a monochromator made by Herrick long ago, back in the 60s and 70s, that we employed for rapid scanning spectroscopy that was capable of doing about 200 scans per second, but it was only useful in the visible range, and it was only useful with a lot of noise and a lot of uncertainty in the answer. So if you've got a monochromator with one or two of these very large gratings, obviously relative to a thumbprint, huge. This is 50 millimeters per side. How do you scan rapidly? It is, in our world, and we're, as far as I know, the only ones doing this, it's with a subtractive double monochromator with moving intermediate slit. So all double monochromators have the light source and then an entrance slit. The first monochromator, its exit slit, a second monochromator, its exit slit to the sample. And that slit between the two monochromators that I called the first monochromator's exit slit is also the intermediate slit between the two monochromators, just different names for them. And that intermediate slit we cause to sweep. So you've got your rainbow of colors, and then the slit, the aperture, scans across it. So we're able to use these very large surfaces for brilliant high throughput, superb stray light characteristics, and couple it with a mechanism for scanning that is moving an aperture in space. So if you have kinetic applications that are seconds and slower, milliseconds, for instance, we're capturing 1,000 scans per second with this particular device, then perhaps you'd like to talk.